Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, I'm back to working on the Apple Lisa. This machine was donated to the channel by AJ back in October, and well, there's been a few videos on the machine already where I've taken it apart and discovered that it had absolutely massive corrosion inside that completely destroyed a bunch of the boards, and it means that I should be able to get this machine working again, but it's going to be a bunch of work. Since taking apart the machine, I cleaned up the CPU board and the RAM board. I took them with me on a trip to visit Alex the cat, who has reverse engineered a whole bunch of Lisa boards. Alex tested out those two boards and they both worked, and Alex was gracious enough to give me replacement PCBs that he designed that I could use to recreate the damaged boards in the Lisa, and also gave me a replacement power supply, which for some reason the machine was missing. Now, where we pick up with this restoration, I was reached out to by a friend, Jarrod, down in the Bay Area, who happened to have a spare Lisa. Well, it was a barn find Lisa, and he needed parts out of it to fix his Lisa. But he said once he got his Lisa together, he didn't need any of the original parts, and he was willing to send them all up to me here in Portland. So the first thing we need to do is let's take a look at all the parts that Jarrod sent in and see which of those parts are going to be useful for trying to restore this Lisa. Unfortunately, there's still going to be stuff I'm going to have to do because the Lisa parts that he sent me is from a Lisa 210 and not the 2.5 that I have, and that means there's some differences on there. But hopefully we still are going to get a bunch of really good parts that I'm going to be able to cobble together along with the stuff that Alex gave me plus some stuff I bought, and hopefully I can start getting this machine back to working condition. So without further ado, let's get right to it. Lisa parts, loads of Lisa parts. Thank you to Jarrod for sending this stuff in. Let's take a look at this, and I'm seeing there's some rust on that connector. So first off, looks like we have a mouse, and this is a rough shape mouse. It is just a standard M100, which is the regular Macintosh mouse. From my understanding, Lisa 2/10s, which is what these parts came from, shipped with this mouse. It was only the earliest Lisas that had the Lisa mouse with the skinnier button. And luckily I have lots of these mice. Next up, we have the motherboard, AKA backplane. Very dusty, but I think maybe it's okay. Notice the pins are not super happy, but let's grab a little pick. I'm actually kind of concerned that these are broken. So they should be really springy like this one, but these ones, they're not super springy. They're just kind of floppy. So that one just stayed. So I'm wondering if there's corrosion on the bottom and it's actually broken. All right, well, those two connectors seem problematic. The two RAM or memory connectors, these are just normal 60 pin. Isn't that the same as ISA 8-bit slots? Maybe. Anyways, those two look fine. But these two, which are both damaged on the motherboard that I have, they don't look super great. These are the unobtainable slots, the ones with this lever situation, and after some cleaning, maybe those are going to be fine. We have a button that looks like the reset button off a regular Macintosh, the mouse connector. These are just normal connectors that we can replace. I can steal these from parts Mac motherboards, which I have some of, but they do actually click. Okay, then we have a bunch of screws. Obviously, those are from the disassembly. Next up, Jarrod sent the CRT board and the flyback from that Lisa 2/10. So that's good to have a spare one of these in case there's any components on the one that I have that are not working, like say the flyback, and maybe these are going to be in better shape. Next, we have the I/O board. Now, this is the one, of course, that got damaged on the Lisa that I have because the battery was there and it's completely wrecked the system. Now, the thing is about this particular I/O board is this is from a 2/10, so it's different and not necessarily compatible with the one that I have. Now, Jarrod told me that there was a bunch of physical damage to this machine. This particular Lisa had been vandalized. I think what happened is Jarrod actually removed a bunch of the damaged components. So crystal oscillators look like they've been removed. Some of these ICs, those also spare. So that IC, these, I think the things that were in the sockets were all damaged as well. Plus some of these other passives. Looks like we have a cut wire. Looks like it's in pretty good shape though. Otherwise, how about on the back? Yeah, I don't think anything really happened on the back, and hopefully the desoldering work is okay. Yeah, it looks like it's should be fine. I mean, there's a little bit of damage here, but I don't see anything that's ripped or lifted. And on the top side, it looks like, well, whoever damaged or vandalized this just used like a screwdriver or something and scratched up these traces. So all of those can be fixed. Now, from my understanding, the main incompatibility issue with this board and the ones from the earlier Lisas is the floppy drive controller, which is that section up there. Here's my board, the one I took out of the Lisa, and yes, see how this looks different up here? As far as I'm aware, whatever's going on up here is the stuff that makes this not compatible. Like, we can't just drop it in to the Lisa that I have. The rest of this does look pretty darn similar. This button here was for the battery. This never had the battery, they just left it off entirely. This section is also significantly different than on this newer revision. Don't know if that has an effect or not. These components must have been removed on the vandalized machine, and they are installed right there. Resistor pack, some capacitors that have been removed, a couple transistors and the crystal have been removed. These components all look pretty similar. That cap is just missing entirely. Notice a few other components over here that look like they have been removed, or maybe they were never there, but maybe that was from the vandalism. Lots of bodge wires on the original board that aren't on this, but I'm assuming this is a different revision. Well, we know it is because the chips are different, so obviously there were some changes. I think what's really good though is a lot of these components, a lot of these ICs and various passives that are on here are gonna work on the replica board that I have. And then I can pull parts off of this board that weren't damaged by the battery corrosion. This whole section up here is in relatively good shape. So we have that chip there along with these two. So I think a combination of these two boards, like I can pull parts off of both of these, like good parts off this, all the good parts off of this, and then put them on the replica board to make one new Lisa IO board. Just noticing this capacitor here, look how lumpy it is. I guess that's the corrosion that got inside. Hopefully this coil is okay. Obviously corrosion got into it, but I assume it's probably gonna be fine. But even these transistors here are corroded. Now I'm gonna hit up Alex and see what he thinks about trying to just repair this IO board, because it's definitely less work to fix this one up. And if this can work in the Lisa, then that's probably the way to go versus trying to rebuild one for the 5/10 from scratch. I'm never gonna use Twiggy drive, so the reality is, does it really matter? All right, here is the next board. It's the CPU board, and this is really odd. Don't get what's happening here. Luckily, I don't really need this. I know that I have a working CPU board. This may be a slightly different revision. I think people who know more about Lisas will be able to tell me, but this definitely is corrosion here. See these traces, they're all eaten up. I don't really get what could have happened to cause that. And on the back side of the board, there's really no evidence that anything bad happened. Here are the ROMs that are on this board for anyone who knows more about this than me: 341, 076, and 075. And the other chip that is relevant on here, 341, 0229. I think this is a PROM again. All right, so there we go, an extra CPU board, no corrosion on it whatsoever. So other than this strange area, this thing may just work as well. Potentially I could transfer, if these ROMs are less desirable than the ones on the other one, I can just transfer those ones onto this board and have one that doesn't even have any corrosion along the bottom edge. All right, next up we have RAM board, and interesting is there are 2 RAM boards here, and I already have a RAM board that works, so now I have 3. Only 2 of these are usable in any one Lisa. I like that these ceramic RAM chips actually have Apple logos on them. No corrosion of any kind, so that's excellent. These are in really, really good shape. The vandalism that happened on this machine happened on the IO board, because if you take the back cover off, that's what's exposed. This stuff is all hidden inside the machine. You gotta take it apart fully to even get to these other boards, which is why these are unscathed. And on the back side, there is some odd corrosion on this actually up here. So this is kind of similar to what's on the CPU board. You can see it sort of eating away. I wonder if there was a bug here, maybe a little spider nest or something. From what Jarrod told me, these boards, other than the IO board, the rest of the stuff was all found in a barn. That's why the motherboard has some rust on the connectors, and it's quite possible there was things living inside of this machine that caused that strange corrosion right here. But I don't think that's something that's not fixable. We just have to clean that up, potentially fix any bad traces, and this RAM board may work. And then we have another RAM board, 512K again. These are TI chips, different brand, and we don't have any corrosion at all on the back here. So cool. Jarrod extracted all the cable harness stuff from the machine, which is great because it's a little bit different than the one that I have, since the one I have is the 2/5, which has a external hard drive, while this one has an internal hard drive. So these cables might be slightly different, but Lisa experts like Alex will be able to tell me what exactly is different here and if I can use this and what changes I might need to make to be able to use this. Now, the reason this might be useful is on the harness that I have, there's definitely signs of corrosion. We have some blue crusties that are happening along the edges of the connectors, and this one definitely seems like it's in better shape. We also have the keyboard connector. It is use a 1/4-inch jack, and the power button. And then this, I assume, plugs into that. And it looks like Jarrod went ahead and sent some extra stuff here. Some RAM. Thanks for the memories. And we have some chips along with, oh, here, Lisa 210 IO board. So Jarrod was probably using this to try to rebuild the machine when he had the vandalized one. Do you feel lucky, punk? Lisa IO board schematics and stuff on a little thumb drive. And we have some 6522s. These almost certainly are rebadged ones from China. Let's grab some acetone. Let's do the old test here. So whatever these were, they were sanded down so the original markings are gone. Then they re-laser etched the shiny plastic, or sorry, they paint them up, and then they re-etched them with a laser. So there's really no way for us to see exactly what this is, but look at all the paint that's coming off. And we look at this, it still has the marking. It's because they use a laser to etch that, but it's definitely not a Signetics chip, whatever this was. Well, I mean, it could have possibly been a Signetics chip, but not really. Usually the bottom of these chips is not painted, so if you do the acetone on the bottom, you don't get anything off. See how it's clean? That's how it is normally on ICs. Acetone has like no real effect. So I wouldn't go so far as to call these fake chips. They've just been rebadged. They might be functional 6522s. I just don't necessarily trust them. Luckily, I have genuine versions of those. And this AMD IC, the Z8530, I think this is a serial controller chip, if I recall. And yes, here on the original IO board, there it is, the Z8530. I think that's serial port. And then we have a keyboard controller and parallel port. These are the 6522s. It looks like we have an extra 8530 there in that tube. And another one there. These look like rebadges as well, actually, now I think about it. See how the bottom, the texture looks so different than the top? Yep, fakeroo. It's the giveaway, too, is that all the markings on the top are completely identical. When on the bottom, we have differences. Like this one has an A, and that one has a C, and this one, the printing looks a little bit different. It says Philippines, but there's a space between the two lines of text, and yet these have the exact same date code, 8603. Yeah. Luckily, I'm pretty sure that I have some of these in stock that are genuine parts. And the last part we have is an MOS 6504. Pretty sure this is actually a 6502 CPU. It just has less pins on it. And this is going to be used for the disk controller. Yes, look at my IO board, 6504. So that in combination with this ROM, this is the disk controller subsystem. Yes, it's running a 6502 core as a floppy drive co-processor. And actually, yep, look at this, 2414 SRAM. We have two of these, they're 4 bits wide. So this is the RAM used by the CPU along with the ROM to actually function as the floppy drive controller for the Lisa. And here's the new IO board. So that's the CPU, there's the ROM, and then we have a 344041. This is probably a IWM, integrated WAS machine chip. Bet you that's what this is for controlling the floppy drive. Very, very common. It's used on the Apple IIc and Macintoshes, if I'm correct with what part that is. And there is our SRAM for the little computer here that's running the disk drive. So Jarrod, thanks very much for sending these chips along. Hopefully these actually work. I'd have to test them in something else. I think I can test these 6522s in a VIC-20. And then these, I can't remember what uses these. Maybe Mac Plus has used these. I could test on one of those maybe. And this one is good on my IO board, so I didn't necessarily need that. Now we take a look at this motherboard that came out of the barn find machine that should have been the Lisa 210. From my understanding is it doesn't have a parallel port because the parallel port is routed internally to the internal hard drive. So instead of using an external profile that would plug into the outside, this actually would connect somewhere internally. I'm gonna have to go find and grab my motherboard because this has 2 ports on it, and I thought one was serial and one was parallel. So let's compare to the damaged one. Okay, here we go. So the layout is substantially different on these two. As you can see, this has this whole extra section over here, 2 serial ports, mouse port, video port, and then 2 buttons. This has 1 button, the video port, parallel port, and then the 2 serial ports over here, along with the mouse, of course. So obviously this motherboard wouldn't fit inside my Lisa because the back metal plate and everything is designed to accommodate this one. But Alex gave me a replica board of this, so hopefully I can transfer over the good parts of this, like these 2 slots, those ones, for instance. And then looking at the edge connectors, they all look the same, except this one has all these pins bridged, but that looks like that's actually just done here with these vias anyways. And I was really hoping for this motherboard that I'd be able to use all of these connectors. I knew these were going to be bad, but hopefully I thought these were going to be good, but obviously these two aren't good, those two aren't good, so I'll have to find some new 120 pin slot edge type connectors. And then we have a speaker that's for the Lisa, so it's cool to have the extra one, although that one's in pretty rough shape, and I'm pretty sure I have something that would probably work in place of that. And then we have some random ISA cards. We have a Crystal Audio sound card. This one's made by Media Magic. It says here, random ISA card number 3. Can you fix it? And then this one here, what is this? This is probably a data acquisition card, I am guessing. Random ISA card number 2, data logger. Yeah, that's going to be data acquisition for sure. This is made by Real Time Devices out of State College, Pennsylvania. These cards were, oh yeah, look, accessing the analog world. Oh yes. And our last card, this is obviously an IDE / floppy drive controller. So this is the floppy controller, and then the IDE port. This just goes directly to the ISA bus because IDE is just an extension of the ISA bus. And this does have a ROM and some SRAM. So there's some functionality happening here. SRAM is odd on one of these. Typically, I've seen a ROM. This thing might have support for large hard drives when the BIOS of your computer didn't allow it. Random ISA card number 1, I have no idea what this is. Well, yeah, it's definitely a floppy / IDE controller. That's the hard drive connector. It probably sets up jumpers and stuff like that. I'll stick this in my pile of ISA cards to test. That'll be for some future video on the second channel. Maybe we'll figure out that this has some awesome, cool feature, although it's highly unlikely this thing has anything cool on it. And ultimately, you could just put XT-IDE in here, and then this could just work on older 286s and 386s that don't support large hard drives, and XT-IDE would take care of that for you and just get rid of whatever ROM is on here. But before I take that out, this will definitely be worth a future test just so we can see if this has any cool features. I just doubt it. I totally doubt it. And then this spreadsheet, which I didn't take a closer look at, this almost certainly, oh yeah, there's schematics. Certainly there's a community project to document this stuff, because since the Lisas are so commonly destroyed, just gives you a list of all the ICs and everything else. So pretty handy to have. And I think, like I said, Jarrod was probably using this in his attempt to rebuild his vandalized one using some of these chips and stuff, but he didn't end up needing to, because from my understanding, the IO board that was in the barn find Lisa went into his better condition, not barn find Lisa, the vandalized one, and he was able to make his computer work. I think it still has some issues with the way the CRT analog board is working, but he said when he turns it on, definitely sees kind of blurry on screen what he could see in the video when I tested my boards at Alex's place. So he knows that the machine is nearly working all the way. So that's excellent. And thank you very much, Jarrod, for sending me all the excess parts. Hopefully, based on information I get from Alex and other Lisa experts, I'll be able to use some of this to combine with those PCBs I got from Alex to make a freaking working Lisa. Awesome. And when you last saw this motherboard, this is the one that Jarrod sent in, it was looking really dirty. So I actually decided to put this and several other boards in my sonic cleaner. I have a large one that can accommodate big boards. And well, this is how it came out. I'm pretty surprised to see that the edge connectors are in quite rough shape. This whole section of solder mask just came off the board. But take a look at these connectors. The board didn't have a ton of corrosion. It just looked really dirty. But I guess moisture had been accumulating on this board for a long time. And a lot of the fingers, which I had noticed looked kind of floppy when I was unbagging everything, well, these are actually just broken, and they completely fell out and fell into the sonic cleaner. I had ideas about salvaging these 220 pin connectors and reusing them on the PCB that Alex gave me, but clearly that's not going to happen. The 260 pin connectors, on the other hand, they're in pretty good shape. Clearly there was a little bit of corrosion on these as well, but none of the pins are broken, so these would probably work fine. Luckily, the 3 expansion connectors on this motherboard are in perfect shape. They were dirty, and I don't think there was any corrosion on them because I don't think any boards were plugged into them. So they cleaned up perfectly when this board came out of the sonic cleaner. That's great, because I'm definitely going to need to transfer some of those onto the new PCB. And while you can definitely buy 60 and 120 pin slot connectors, these ones I'm sure are, if you can even find them, extremely expensive. So I'd rather just take these off one of these boards and put them onto the new PCB. Other things I think I'm going to salvage off this board to transfer over to this are these capacitors along with these inductors, and these two over here. I might reuse that IC as well. That was actually just in the board when I had it in the sonic cleaner. I might as well take those components off as well. Just keep this new one as original as possible, even though obviously the purple color is not particularly original. Obviously, I am not going to be reusing any of these connectors. They're in very rough shape, and luckily the footprint is all just standard stuff, so I can use modern things. The resistor packs I'll probably transfer over. That one looks a little blue. I don't think it should look like that. Maybe this one is in better shape, although I think these are about 50 ohm resistors on each of these lines, so it doesn't really matter. It's not particularly critical. These two resistor packs in that location are not used on the new PCB. It doesn't have them in that location, and I think those have to do with the parallel port signals that is routed internally through this edge connector up to the internal hard drive on the Lisa 2/10, which is where this motherboard came from. Now, while I had the sonic cleaner out and filled with liquid that was good at obviously removing corrosion from these boards, I decided to throw in this one as well. This was the motherboard from the 2/5 that I got from AJ that was all destroyed. And I wanted to see what would happen with all the corrosion that was all over this if I put it in the sonic cleaner. And well, I'll be darned, this thing cleaned up really, really well. Now, this particular board I had in the sonic cleaner for maybe about 50 minutes, 50, and you can see that there's still corrosion left. But I'll insert some video here from how this board looked before, and you'll notice it looks horrible, and now it's actually looking pretty good. I'd say if I had to reuse these 60-pin connectors, I probably could. The edge connectors, it's not great, but it certainly still has the plating on it. But we know that there are tons and tons of broken traces on this board. I found a bunch of them just in this location alone. And you can see how the traces are all sort of wrinkly in this area, and that's because there's corrosion underneath them. And absolutely, these are just broken traces. So the PCB itself is not really usable, but a lot of the other components on here actually seem okay. I mean, I'm not sure I'd want to use these resistors just because they were completely green and crusty, or the capacitors, but a lot of these components don't look super bad anymore. In fact, for these two resistor packs on the serial ports, I'll probably take this one and one of the ones from the other board and reuse those. And look, even these ports aren't that bad. I mean, they're bad, but they cleaned up a lot. Look at these ceramic caps. The corrosion actually ate away and the actual covering fell off these ones. I mean, this one still has part of the covering, but that one is just completely, well, exposed. One thing I noticed I'm gonna have to ask Alex about is the parallel port seems to have these resistors. Now, this single band, I think that just means actually that that is not a resistor, that's more like a jumper link. And on the new PCB, it doesn't seem that those are there. I'm assuming if we flip this over, there is, yeah, different routing that just routes these traces directly to where they need to go. So Alex probably improved the design by skipping out the need for those. And actually, taking a look at the bottom of the original motherboard here from the 2/5, look how these traces have been cut and some bodges or these resistors have been installed. And then on the top side, well, these jumper links, I guess, were installed. Yeah, oh no, these maybe are resistors actually. It's just that one is not, but these other ones are. So I'm not sure what the deal is with that and why that's different than what's on the new PCB. Unfortunately, going through the sonic cleaner did not fix this switch. This is the reset button. It's completely jammed still. And I still don't have a good replacement for this. I think this is a completely easy to find switch. I just haven't ordered one yet. And I might just try to find one in my stash of parts that is gonna work. I don't really care that it looks exactly the same on the new board. The other thing I don't have right now is the video connector for the video out. Now this isn't really necessary, nothing really uses this. The Lisa video is not standard NTSC, so you can't just hook up a normal monitor to it, but Apple installed this anyways. This one is very corroded, and even after the cleaner, it does not look great. But I have to admit, the one that was on the barn find Lisa is in a lot better shape, and I think with a little bit of polishing, this will probably work okay. So I'll probably reuse this one just because these are sort of older style video connectors, and I don't happen to have any of these. Now on the original battery damaged board, this was the only expandable slot for the expansion connectors that was corroded, and it cleaned up completely in the sonic cleaner. Maybe some of the plating is removed from the top edge. I don't really notice a difference between these other two, but it's so nice that these cleaned up well, and so did these. That means I have 6 of these to pick from to put onto the new PCB. So for the journey of getting this Lisa back together, I'm gonna need to kind of break it up into parts. And the first thing I think I'm gonna work on is the motherboard, the core component that bridges all the various boards together. When it comes to the rest of the boards, well, I already know that the RAM board that I tested at Alex's already works, as well as the CPU board. These are the two that came from the Lisa with the battery damage. I also have the additional CPU board and 2 more RAM boards that came from Jarrod from that barn find Lisa. What's left after that is getting a working I/O board, and I have the one from Jarrod, I have the original one, and I have this replacement PCB that Alex gave me. I'll talk about my plans for what I'm going to do on this after I work on the motherboard, but really this, plus all these boards we just looked at, and this power supply should allow me to kind of get the machine to a state where I can power it up and see if it's even showing signs of life. And I mean, it should, right? We've already tested some of these boards. It's just a matter of getting all these other ones situated. So back to the motherboards. I think first things first is I'm going to start populating components onto the new one, things that I actually have. Now I went ahead and I actually found some 120 pin slots along with some 60 pin slots. I got these from AliExpress. They were relatively inexpensive even with the tariffs, although they would have been a lot cheaper before the tariffs. These will allow me to populate these 4 slots onto the new PCB, the new motherboard PCB. I also went into my stock and found the right connectors, so a mouse port, parallel port, and 2 serial ports. Then I'm going to start salvaging components off of these 2 motherboards. So I'm going to take these 3 slots off of the Jarrod motherboard, along with all the inductors, the capacitors. I'm going to steal that resistor pack, this resistor pack to reuse on this board. I'll take the video jack, as I talked about, off this one to transfer over. I don't need those resistor packs. I think I can reuse this IC. It's an LS132, but that one looks actually pretty corroded. So I'll probably find one of those in my stock, but I have sockets to install onto the new board for that component. Then I'll go into my stock of parts and hopefully I'll be able to find the capacitors to install on this board along with these resistors and these 2 transistors. I don't really want to reuse those because that obviously had the brunt of all the corrosion on there. And I'm noticing now that this 2/10 motherboard doesn't even have those components on it. So that's obviously for some component that Apple decided not to have on the newer motherboard. Okay, so I'm going to get started. It's going to be a little bit of a build montage. I will come back once it's done, or if anything comes up that is bad. Here's the high-speed build montage. I'm not going to do any music, I'll just do a voiceover. So this board is 4-layer, which means that getting things off can be kind of difficult. You really have to use hot air, but blasting it with hot air while desoldering makes quick work of it. I got the connector out pretty easily. Sometimes if the solder is corroded on the bottom side, can actually make it really difficult, but luckily it seemed that for the green board, the one from the battery damage machine, is quite easy to get this connector out. First thing is I'm just going to get out one of the connectors and just have to clean up the pins a little bit. And now I'm going to work on the purple motherboard. These AliExpress slots look really good, perfect actually, and they fit into the board without any issue. Of course, one of the pins was bent, so a little bit of rebending just fixed that right up. The 60 pin connectors are the same brand. I bought them from the same supplier. It's always good if you're buying one part to just buy them both from the same supplier, just saves on shipping. And I'm fitting the single expansion slot that I removed from the green board. I was really happy all the connectors fit right into the new PCB without any issue, and now I'm fitting all the expansion ports, which also fit perfectly. Alex did an amazing job designing this particular PCB. Now I'm just soldering on the corners of all of the connectors. I like to do this with all of these large components, so I just do one corner or maybe 2 corners, and then I'll push down with my fingers and then reheat the joint just to make sure that it's sitting flush against the board. Since I'm not using some special jig to build this board, it's quite possible you could solder one on and one of the connectors would be offset or tilted over a little bit, and you don't really want that. So all the slots are going on now, and I'm just doing the corners on those as well for the same exact reason. I was really relieved when I removed the expansion connector from the green board that the holes in the board, the actual vias, were quite large. It just made removal of the slots very easy, and Alex used the same size holes with this new PCB as well. Just made placement of the parts really easy and not fiddly. Next up, I'm back on the barn find PCB, and this PCB, while the top side cleaned up really well, the bottom actually has quite a bit of corrosion, and some of the things are kind of hard to remove. But I'm removing all of these inductors and capacitors around the ports. I know there's going to be some contention that I'm going to be reusing these parts. Well, they look correct on the board, and I like that. But also, they weren't exposed to all that battery damage corrosion like the ones on the other board, and I think they're going to be perfectly good to be used on the new one. Plus, they're going to look exactly the part because these are from the original machine. I'm also taking off the 1 axial capacitor because I actually don't have any of these. And I know people are going to be shocked about reusing an electrolytic cap like this, but you'll see later on I'll test it and it'll actually be completely fine. Right now I'm removing these resistor packs that are around the ports, and I did test them and they all work on all of the lines, so they should be completely good. It came off the board relatively easily, although some of the solder is corroded on the bottom side and can make desoldering kind of a pain. All the capacitors here, the disc capacitors are coming off. I could just replace these, but I like the way these look, and I don't have any that look like this anymore. The new ones look different, and I'd rather use the original ones. Now I'm just making a little map of all the resistors, and I'm checking their values, and this is on the board that's corroded. This actually is the video output circuit for the composite video, so I'm just writing down all the values on a post-it note and checking them, and luckily all the resistors except for one are good. The axial cap from the barn find Lisa has a reading of 1056 microfarad and 0.1 ohm ESR, so totally fine to use. I'm not worried about this good quality cap. Now comes the process of installing these passive components back onto the new motherboard. Of course, remember this is a mix of old parts that were salvaged and some new parts. Some of the parts were very fiddly, especially the little inductors, because Apple, when they installed them originally, they cut the legs on the bottom side of the PCB very, very short. So even when you place them in the new board, the legs don't really stick through, which is kind of annoying, makes it hard to solder, and just make sure they don't fall out when you're doing it. But a little bit of tape, a little bit of blue tack made quick work of it in the end. I took a look at Alex's repo for the reproduction board, and he said that the video output circuitry, which is what I'm working on here, is completely optional. You just won't have the composite video output, but I decided to go ahead and install all these components. I looked through all my stock of parts that I had, and I had all the required parts. Well, close enough. I mean, if it said 2.3K and I had a 2.4K, I installed it. I don't think it really is going to make much of a difference at all. It is a monochrome video signal that I'll probably never use anyway, so it doesn't really matter. You might be noticing I'm using one of those component leg benders. I have to say it's pretty handy. I don't generally use it because I don't really build a lot of kits like this, but for multiple resistors where you want them to all look the same, worked out pretty well. The one passive component I actually removed from the battery corroded board was the little disc capacitor for the video generation circuit. It's 68 picofarad, and I looked through my capacitors and I couldn't find that exact value. So I took the one off that board, I tested it, tested fine, and I reinstalled it. Hopefully that will not cause any issues. And here's the ultra high-speed montage of me soldering all the pins for all the expansion connectors and all the D-sub connectors. I'd only done the corners, so now it's time to do them all. Always make sure before you do this step that you have the connectors completely seated flush. Otherwise, you're going to be in a world of hurt if you realize you have to desolder 160 pins or 120 pins to try to get a connector seated correctly. The 10 seconds to check it before you start this work saves you a huge hassle. And the board is all done, and it looks awesome. There were a couple bridge solder joints that I had to fix along the way, so I had used a little bit of solder wick for that, but yeah, it looks awesome. I'll have to clean the flux off, obviously, but it's gratifying to see the board like this. But wait, I'm not done. I'm eager to move on, but I realized that I really should just deal with the fact that I'm missing those two expansion connectors. So I'm going to go ahead and remove the other two expansion connectors from the green board. I'm removing the middle one, and I removed the one that was on the far left edge because those are the two that didn't have any corrosion originally. My intention was to remove one of the barn find connectors because those had never been exposed to any corrosion. Unfortunately, well, things didn't quite go to plan. Over on the barn find Lisa, it actually looks like, unfortunately, that right under the connectors there was probably some kind of a critter living there, maybe a spider nest or something, and it really corroded the solder. And if you know solder, when it gets corroded, it becomes porous or something happens to it where it becomes really difficult to apply heat to it. It doesn't really want to melt if you apply a soldering iron to it, or even the desoldering iron really doesn't do anything. So I decided to go back to the green board and just remove the final third expansion slot, the one that did have some blue crusty on it. And if I have to use it, I have to use it. Luckily, it came out of the board really easily. Even though this board had all the battery damage, there just wasn't any corrosion on the bottom side. So I applied a bunch of flux onto the barn find one on those corroded pins, and I got to work. All the other pins that weren't all sort of corroded and porous looking, those desoldered without any issue, just a little hot air, just like on the green board. But when it came to those pins that were corroded, I did manage to finally get it, but I had to blast the board with so much heat, 350 degrees Celsius, really close, and it actually started to damage the board. But I guess what did I care? The board was already damaged, so big deal. In the end, I got the connector off, and you can see that all the ones I removed look really good, which is excellent. I'm just not sure about the one with the corrosion on it, so I marked it with the C, so I'll use that only if the other ones don't work properly. Now I'm in the home stretch for this motherboard. I'm just reattaching those two expansion connectors, and then I'll be done with the motherboard. So the motherboard should be pretty much ready to go. The only thing missing is I haven't installed the LS132, I think it is. Yes, 132. And I don't have an appropriate reset switch. As I mentioned, this one here is completely ruined, And I looked through all my parts and I just don't have anything that will work for this. Now, I just have regular push buttons like this. So for testing, when I get to that point, I'll just solder some wires on and connect a push button like this so I can easily reset the machine if necessary. The one thing I didn't really mention in the video is that I took this video connector off the barn find Lisa and then I put it into the sonic cleaner. And it looks like it took off all the plating, which is why it's sort of a copper color. I painted it with some clear lacquer, so that's not going to corrode. And then I sanded down the opposite side of this little tang and the outside of the RCA connector itself. The way these work is when you plug in an RCA connector, obviously the ground or the outside of the connector touches this. That has to be actually nice and clear, but also the single pin that sticks through the connector actually rubs into this little tang. In fact, you'll see if I push this all the way on, it kind of bends it. That just seems to be the way it works. I can't really show it, but I did sand that down with the Dremel as well, just like I did the outside. And hopefully that lasts. If not, then I will just have to replace this at some point in the future. The one expansion connector I didn't end up using was the one that was corroded. I wrote a C on there. That was the one that was in this position on the green board, and that had the blue crusties in it. I just was worried about some of the plating having come off. On the Lisa, these expansion connectors are labeled 1, 2, and 3, and I don't know if the slots are all the same like ISA slots or they're more like Apple slots, on Apple IIs that is, where slot 0 or 1 is on the left side and it matters where you plug the expansion cards into. If one of these stops working because of a bad connection, of course, I'll have this extra one. Plus, I have these additional 2 more on the barn find one that I can remove. Although I mentioned in the montage that removing this was quite difficult. You could see the damage to the board because I had to use an extreme amount of heat to try to counteract this oxidized or damaged solder in this area where whatever critter was living caused all the corrosion. All of these pins came off with no issue, but over here I just could not get heat transferred into it, hence the need to absolutely blast the board with enough heat to melt the solder underneath the oxidized coating or whatever's causing it not to accept heat. With all that said, I think I'm pretty much done for the motherboard for the time being. Now it's time to turn our attention to the I/O board. Now this is the I/O board from the battery damaged Lisa, and while I had the sonic cleaner out, I ended up putting this in there as well. And I think I had it in there for about an hour because I would put it in, run it for 10 or 15 minutes, take a look, and there were still a lot of crusties on there, and I just kept putting it in until pretty much all the blue crusties are gone. And I'm frankly shocked at how good this thing came out after being in the cleaner. There are some small areas here and there that do have some crusties on there, these components and that IC, but for the most part, this board cleaned up incredibly well. I suppose I could have run it even longer, I just didn't really see the point because I'm not going to be using this board, obviously. All of these black dots you're seeing is the corrosion underneath the solder mask, and easily we could have broken solder joints all over this board. So it's just not really worth my time, especially since I have a replacement PCB, to try to revive this particular board. You can see along the bottom of the board, tons and tons of corrosion. Obviously that all originated here from the NiCad battery pack, and it made its way through capillary action up the board as well, up into this top corner. As we move over on the top edge of the board, the corrosion pretty much stops. It's obviously down here along the bottom edge, but it doesn't really make its way up here, which is good, because I might need to steal some of these chips for what I plan to do to revive this machine. Up in the top corner, I removed these ICs for sonic cleaning because they were not damaged. I didn't really want to put the chips in the sonic cleaner if I didn't need to. This was the 6502 processor that is used for the disk controller. This is the ROM chip for the disk controllers. Remember, this is a whole little computer. This is the RAM for the disk controller, and this was a little state machine. I think it was a PAL chip that is all part of this controller. If we move back down a little bit into the middle of the board, I took these chips off because they were a little bit corroded, but I might try to reuse them. There are 2 6522s. Luckily, those are relatively common chips. And then we have the serial I/O controller, the 8530 from AMD. There's still some green crusties in the sockets, but that's fine. I'm not going to be reusing that. The rest of this stuff is all just jelly bean logic. And now we're back down to this part of the board where we have a bunch of corrosion again. On the back side of this board, there's also plenty of corrosion. It's amazing how the battery corrosion made its way to the backside of the board, either through the vias or maybe around the edges of the board. I'm not really sure the mechanism for that, but all of these traces are severely damaged on the backside, and the damage pretty much extends all the way over to this area. But if we go up to the top of the board, the backside is looking pretty good. Don't really see anything. I mean, maybe there's like the odd dot here and there, but those traces are probably fine. There is a lot of corrosion up here. This was the battery charging circuit, so I guess it kind of crept up the board on the backside, and it's corroded right there as well. But obviously the primary area of corrosion was down here. The battery was mounted on the other side of the PCB right here, and you can just see how much damage there is. What is amazing, to me at least, is the gold fingers that make the edge connector pretty much fine. There's a little bit of that green crusty on there, just like there was on the CPU board and on the RAM board that I had to clean off. But other than the plating having come off a few of the fingers like this one, which is mostly copper, and that one there, it's in pretty good shape. Same for the other side. We have some of the plating that's removed from a few of these, but generally I bet you if we plug this into a connector, this would actually work if the rest of the board were not damaged. So when it comes to getting a working I/O board, I have two things I can do. One of them is I could just build a new I/O board on this replica PCB that Alex gave me. It's an exact replica of the I/O board that was in this machine, the 2/5 I/O board. And if I built this up and spent all the time to source all these parts and install sockets and everything, then I should have a working Lisa at that point. But I think I'm going to take a little bit of a shortcut with my other option, which is this, the I/O board that Jarrod sent me. Now, this is not the one that came from the barn find Lisa where all the other parts came from. This actually came from Jarrod's Lisa, the one he originally had that had been vandalized. And because when you open up the back of the Lisa, this board, the I/O board, is just sitting there facing you, it seems like some kids or whoever vandalized this machine vandalized this board by taking a screwdriver and just trying to pry out some of the chips. And they caused a little bit of damage on here, but on further inspection, the damage is not that big a deal. And as I mentioned, the big difference between these two boards is the disk controller subsystem and the lack of the battery circuitry. So there's no charging circuit at all, that's up here, and there's just no battery installed. So these ones never have any battery damage. But the disk controller on the 2/10 is designed to only work with 3.5-inch floppy drives and not the original Twiggy 5.25-inch drives that this one does support. So to facilitate that, Apple changed the firmware that runs on the 6502 CPU, and that is these two sockets, and then they added the IWM, the integrated WAS machine, which is the disk controller used on the Macintosh and with the Apple IIc. Now, unfortunately, the IWM chip is relatively rare and not super common, and that was one of the missing ICs that someone had removed during the vandalism process. But I happen to know I have at least one of those spare chips that I can use without salvaging it off a working computer. Someone gave me a Macintosh SE where the battery leaked and destroyed most of the motherboard, but I should have the original chips that were savable from that machine, including the IWM chip, which should be a good fit for this machine. I reached out to Alex to figure out if this 2/10 I/O board was compatible with the 2/5 Lisa, the rest of the Lisa that I'm going to be using, and he said yes. The biggest difference is the disk controller on the 210 board actually generates the PWM, or the variable speed signal, that the 3.5-inch floppy drive uses for the custom Apple format on their 400 and 800K drives, while on the Twiggy one, that is generated off board on a separate little circuit board that's installed inside the Lisa over by the floppy drive. I will need to modify that board to bypass the circuitry that's on there, since those PWM signals will already be coming directly from this 2/10 I/O board if I use this in this 2/5 Lisa. Basically, long story short, is that this I/O board, which I think is going to be easier and quicker to fix than building a new one from scratch, is going to work inside the Lisa that I have with some simple mods to the Lisa, and I think this is the right way to go. So let me start by figuring out exactly what's been removed from this board and starting to get all those components like sockets and passives and things reinstalled so that I'm that much closer to getting this machine up and running. So I'm really glad that I have both of these I/O boards, because really for the most part, these are the same board except for the disk controller section and the little charging circuit. So it's really easy for me just to compare these two boards together and figure out exactly what's been ripped off. Here's an example: axial cap, this transistor, that capacitor, this capacitor, this capacitor, that capacitor here. I actually did a little bit of that work off camera already, and that's what these marks are on the damaged board, just indicating what components I might need to steal and move over to the other one. I want to try to not reuse any of these axial caps. So I need to try to find something that will be appropriate and fit in the board. But for some things like the crystals, I may need to reuse the ones that are on the board. In addition, these two transistors were also removed from the vandalized board, but these really cleaned up well, and there's very minimal corrosion up in this area. So I have a feeling these probably work, and I can test them once I remove them from the board. Now, one component that I never really stock are axial caps. I just never really change them, so I don't have a reason to buy any. But I did happen to have these brand new caps, and they are larger at 220 microfarad at 16 volts. The caps that were removed from the vandalized board, if I take a look at the damaged one, 10 microfarad at 16 volts. So obviously 220 microfarad like this one is going to be far larger than these, but I don't think that's really going to matter, because I'm pretty sure this stuff is just bulk capacitance for power rails. And to be honest, if there's more capacitance around the board, I mean, really, it doesn't matter. I guess the biggest problem is there might be a bit more inrush current when the computer turns on that could potentially cause an issue. Another possibility is using normal radial caps. Those are the standard ones where the 2 pins come out of one side, and you just lie the cap down on its side and you bend one of the legs around and down into the board. I've had to do that before where I'd had no other appropriate cap to install, but in this case, I am just going to use these. I'll just test these first because I don't even know where I got these, and just make sure they at least look good in the tester first. Well, we're not off to a good start. This one is completely dead. And I do have it in the tester correctly, so the negative side is over here on the negative terminal. Even switching over to clip leads, we get the exact same rating. All right, so this cap is completely dead, and that means this whole bag of caps is probably not usable. Let's just pick another random one from here just to see if it is the same. Oh, you know what? This one is actually a bit better, and we're at 1 kilohertz. If we change the frequency down to 100 hertz, 0.7 and 209 microfarad. Doesn't seem terrible. Maybe the ESR is slightly high for a 16 volt cap. I just put another one on and it tests basically exactly the same. These are Nichicon caps, by the way, in case you were wondering the brand. I'm very surprised that one of them was completely stone dead, because so far that's the 3rd one. It tests exactly the same. So it looks like I need 8 of these caps. So I'll just quickly test 8 and then we'll go from there. One other thing that's good that I have the replacement and it doesn't look like it's corroded or anything is this is not just a normal resistor pack where all the value is the same for each of the pins. Apparently this is like a little DAC. Maybe it's used for sound, I think Alex told me. And it has various values in there and they're high precision. So you can rebuild it with individual resistors. But of course, if you want your sound to work properly, you have to use high precision resistors. So it's good I could just take this off here. And there wasn't a lot of corrosion in that area. So there should be no problem with that component. I am going to steal these 2 crystal oscillators because I'm pretty sure I don't have these exact values. So those hopefully are going to be no problem to transfer over. I'll obviously have to install sockets for these 3 ICs. I could try to take these 2, but I really don't want to. And these are old single wipe sockets and don't work that well. This IC, by the way, is not used on the Lisa. So even though there's a socket there on the other motherboard, it's just not necessary. But for these 3, well, I was hoping I could use some of these sockets, which I found in my collection of parts. These are new old stock Texas Instruments sockets. And I took a look at the back and there's a date, June 27th, 1977. But unfortunately, these are just 40-pin sockets, and unless these 3 are damaged, which I don't think they are, probably a little deox, it's going to be all those are needed. I don't have any of these 28-pin sockets, well, at least in this new old stock stuff that I can put on here. I just thought it would be kind of fun to use these new old stock time correct, well, actually a little bit older than this board, but still, these are old, and it'd be kind of cool to put these on here, but I'm just going to have to use more modern stuff, which luckily I have. These sockets are probably all fine. Everything looks good on the rest of the board. So yeah, it's really just the crystal oscillators, these 2 large transistors, the small transistors. I think, no, there's no diode there that I have to worry about. All the caps we talked about. Oh, there's actually a little cap. I'll just try to take it off this board and install that into the C10 position. Oh yeah, 2 more transistors right there, so I'll have to look up those, plus another crystal oscillator, so I'll steal that. There's a resistor R54 that's missing on this board, but that doesn't exist on this, so I'm not sure that's going to be necessary. I'll have to check maybe some photos of other 2/10 IO boards to see which components exactly are there. We have a couple capacitors here that look like maybe they were ripped off, and potentially this part as well, and those don't exist on this board, so I can't really compare apples to apples there. Right, so you know what that means. Time for another build montage. Here we go. Welcome to Adrian's salvage operation. I'm starting by making a map of all the components I intend to move over. I'm not going to put them all there, but the ones that I might mix up, I am doing. So transistors and the crystals. A few of the transistors I couldn't read off the part numbers that are on the damaged board, so I had to refer to the schematics, which Alex has on his GitHub repo, so I was able to look up the part numbers. And now it's just removing them. I'm starting with the crystals first. Hopefully those aren't damaged. I don't really have a way to test those, but they should be easy enough to buy if they aren't working. 2 of them handle the serial ports, and 1 of them is a 16 megahertz clock that's maybe for the whole computer. I'm not sure what that one does. I also removed that special resistor ladder that's used for the DAC, and now I'm working on those 2 high-power transistors, which I think are used for the audio circuit. I'm testing them in my little tester, and just to make sure they're good, and they both look good, so they're going into the new board. Now I'm finally installing some of the components into the new board, and new as in the 2/10 board from Jarrod. I'm using blue tack to hold things into place. I really have to say I love this stuff. It's very useful, and yes, it does melt a little bit if it gets too hot, but it usually comes off without too much fuss, and I don't think it's too toxic at least. The crystals go in with no issues, as does the resistor ladder, and I had previously cleared those holes actually off camera, so everything went in really easily. I'm now looking for the transistors to put in the board that are coming from my new stock. Unfortunately, I'm missing a couple of them, and I spent a little while looking for substitutes, but I wasn't able to figure out what a good substitute was. That's something I had in stock. So I ended up just taking the 2 transistors, this is up by the 16 megahertz oscillator at the top of the board, off the original battery damaged board, and I reinstalled them into the new board. I did test them first. They tested fine. They seem about equal, so hopefully that circuit works. Once the system is powered up, I'll be able to check the clock with my scope, and if it's not, then I can suspect that those transistors might be bad. Now it's time to start fitting my probably contentious caps that I'm going to be using on this board. Not only are they unknown, but they're also the wrong values. And I have a feeling people are going to tell me that this is bad somehow. But I got to tell you, I have done substitutes like this so often, and I generally never run into issues. As long as they're not used in critical timing circuits, it's really not a problem. Just make sure the voltage rating of these caps is at least equal or higher than the ones that were in the board. And in this case, they were both 16 volts. So it's really just the capacitance or capacity of these capacitors that's more now. I'm fitting that bodge wire that, maybe it's not a bodge, I don't know what it does. It brings power from one part of the board to another. The original one was relatively thick, so I used a pretty thick, solid piece of wire to replace it, just in case it's carrying some current and load. Next up, I noticed that there were a couple small bypass caps that were missing in the upper right corner of the board, and I checked a photograph of this board on Wikipedia, and that one had it. So I actually stole a couple of the exact matching bypass caps from the original battery damaged board and transferred them on. I could have used anything. I have tons of those bypass caps, but I wanted them to match. So that's why I used the existing ones. But I took them from the battery damage board in the top left corner where there really was no battery damage. The last thing to do is install 3 sockets in the board. And instead of using just cheap AliExpress sockets, I actually grabbed some really good ones. I have some gold coated ones that are name brand, and they're the round hole type, but they really hold the chip firmly so the chip will never come out. And that's what I'm going to use on this board. It totally deserves it. I decided that before installing them, I probably should check to see if any of these traces that are scratched underneath the sockets are actually ripped. And that's because these sockets will completely cover the traces. So I need to make sure that everything is toned out. So I spent several minutes toning out everything that looked kind of suspicious. And in the end, everything was fine. So I grabbed a little bit of lacquer just to cover up the exposed copper, since it will never be seen again once the sockets are installed. And I just made sure those are covered before soldering on the sockets for good. And here we go. It's actually time to start reinstalling components. So because I'm reusing these old single wipe sockets, I'm doing deoxit first. The chips I'm installing are the ones that actually came off the battery damaged board, but these were actually in the ultrasonic cleaner and look pretty much perfect now. So hopefully they work. If not, I'll be able to find substitutes. These chips are not rare. The 6504 processor that you can see installed in the upper left corner, that is kind of rare, but Jarrod sent me an extra one that he had. So hopefully that one works if this one is bad. A few of the pins on one of the 6522s were a little bit tarnished, so I used my polishing bit on the Dremel just to clean them off before I installed them. Next, I'm breaking into my collection of Mac SE parts. This came from a battery damaged Mac SE that was really severely damaged. I saved all the chips from the motherboard, including the IWM or integrated WAS machine chip. That's the disk controller that this machine uses, along with the 2C and several Macintosh machines. I then noticed I had missed a resistor that is actually supposed to be on this board. I looked at the photograph on Wikipedia of the 2/10 IO board, and it had that resistor installed, but the color bands were not really very clearly visible, so I scoured the internet looking at other pictures just to try to figure out exactly which resistor was missing, and it turned out it was the exact same value just based on the bands I could see on the photographs as the resistor right below it, so I just measured that, and it was 10K, so easy peasy. I'm actually in the home stretch with this IO board. The next thing I have to install is that microcontroller that came from the battery damaged board. That thing is critical for the operation of this, and it was missing from the board that Jarrod sent, so luckily I took it off the other board, and it seems to be in good shape. Now, the next thing is I do need to program a ROM to run the disk controller, and it needs a 2732, but I couldn't find one. So I'm just going to use a 2764. It has an extra address line and a couple extra pins, so I just installed a little resistor to address line 12 to pull it down to ground, 4.7K. From what I can tell, looking at the schematics, the 6504 on this machine doesn't seem to actually route that pin over to the EEPROM. I guess Apple never thought they need to have an 8K ROM for the disk controller. And lastly, the very last thing is, I noticed that there were some pins on the bottom of the machine that were kind of bent up, and some of them were almost touching or were touching. So I spent a moment just checking things over and bending those pins away from each other so that would not happen. So there it is, the completed 2/10 IO board, hopefully all repaired. You just saw in the montage, this is a mishmash of old and new parts. And I don't know for sure if all of the stuff that came off of the battery damage board is working, but after going through the sonic cleaner, there's no obvious corrosion on any of these ICs. I tested everything I could, like the transistors and any of the capacitors I moved over, like this small black capacitor, and they all look good and matched what's in the schematic, according to my little tester. Obviously, if the transistor could be new, I used a new part, and then the crystals, well, there's no real way to test those. And yeah, I mean, that's it, other than the fact I'm using these larger than I should capacitors, but these are all on voltage rails. So if anything, the power should be smoother because of all the extra bulk capacitance on here. And how freaking exciting is that I am that much closer to actually having the Lisa up and running. Unfortunately, even with these two boards done, there's still a bunch of work to do. In the next video, I'd like to take all the cards that I've worked on the last couple of videos, install them into the card cage, and then try to bench test them. To do that, I'm going to have to work on the power supply. So I need to open this up and see what the deal is, if it looks good inside, check some caps and things like that. And this is a 240 volt power supply, so I think I'll need to do some conversion process if that's not already been done. But unfortunately, just hooking all this stuff up is not that easy because the wire harnesses that go between the motherboards and say the power supply, or the ribbon cables that go to the front panel where the power switch is and the keyboard, all of those cables are damaged and corroded as well. So I'm gonna have to try to figure out how to clean them or replace them, or maybe use the ones that Jarrod sent me. So that's why I'm not just doing some testing in this video. I'm just not quite there yet. If the bench testing goes well in the next video and we get some signs of life, like a splash screen of some kind, then I think the next phase would be to check the CRT board over, get the machine reassembled to some state where I can actually start to run it and see if it all works as a working unit. I've gone ahead and ordered the adapter so I can use a Macintosh keyboard, like a Mac Plus keyboard, on the Lisa, since I obviously don't have the Lisa keyboard. I have lots of mice that I can use with it. It just uses this normal Macintosh mouse, so that's taken care of. And yeah, I mean, I think I'm relatively close to getting this machine up and running, but the next video is really going to tell when I bench test it to show if we have maybe faults on this IO board that keep the system from running, or who knows, there could be a myriad of problems that I might run into in the next video. And with that, that's it for this video. A huge thanks to Jarrod for sending me all these parts, which made it possible to shortcut a bunch of the process here to get that much closer to getting the machine working. And of course, a huge thanks to Alex for giving me these PCBs for the motherboard and the power supply and all the help on testing my other boards. If you've enjoyed this video so far, I'd appreciate a thumbs up. If you haven't, you know exactly what to do. Huge thanks to my members and my patrons that make it possible to do this full time. If you want to become a supporter, you can do so. There's links down in the description below. And of course, subscribe if you haven't already. It really helps me out. Plus, you'll be able to see the progress on me repairing this Lisa. I'd love to hear your comments and your thoughts about what I've done here. And if I've made any egregious mistakes, definitely let me know. And I guess that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.